Hi, welcome to class today. Today what we are going to be doing is we're going to be focusing on a certain kind of function called a piecewise function. Now you were introduced to a piecewise function back when we talked about linear functions, and I told you that we would come back to this and spend a whole day on it, and so that's what we're doing. So just a couple of key things I want to go over before we really get into the heart of the notes. A piecewise function is a function defined by two or more equations. Each piece of the function applies to a different part of its domain. An example is shown below. Y equals, and then x minus 2 if x is less than or equal to 0, and then y equals 2x plus 1 if x is greater than 0. The expression x minus 2 gives the value of y when x is less than or equal to 0. The expression 2x plus 1 gives the value of y when x is greater than 0. So, again, it is a function that is two or more pieces to create a line. This first example that I have for you is how is f of x equal to 2 absolute value of x related to a linear function? And so, yes, this graph right here could be viewed as the function f of x is equal to 2, the absolute value of x. That's what it could be. Or we could view it as a piecewise function. If we view it as a piecewise function, we could easily say that this graph has two pieces, 1, 2, that meet at the vertex. Okay, so let's go ahead and write that in. Is graph has two pieces that meet at the vertex. Okay? And so what we're going to do is we're going to come up with a rule for this piecewise function. So when x, why don't we go ahead, we have to remember that it has to remain a function. So if I talk about my vertex, which is 0, 0, so like let's say x is greater than or equal to 0, then it's going to be my function increases up to right 1, up to right 1, up to right 1. And the starting point is 0. So the equation for that would be y equals 2x, and then it's plus 0. We don't really write that. Now we have to talk about the other piece. And so this is when x is less than 0. And so this is where it's not going to equal 0. It's going to be less than, because it cannot equal 0 at the same time and still be a function. Again, we'll write the equation of that line. And so for this one, we go up to left 1, up to left 1, up to left 1. So we get negative 2x. Now what we're going to do is rewrite this so it looks like a piecewise function. So it's going to look similar to what we have up top. So you can write it as y equals. You can also write it as f of x equals. And so my first function is going to be 2x when x is greater than or equal to 0, and then negative 2x when x is less than 0. And then we just have the squiggly bracket to signify that it is a set. Okay, and so that is how you write the rule for each of the functions, is you just break it apart into pieces, you state at which end does it work, okay, what kind of end behavior does it go with. Okay, so let's go ahead and actually make a table and graph some of these, and we'll talk about the domain and range. So we'll start with number 1. So for this first one, x is less than 0. So I do need to include when x is 0. The reason I need to include it is we need to talk about what's going to happen at 0, and we'll just signify that with an open circle when we graph it. So if I put 0 in for x, x plus 3, or 0 plus 3 is 3. Then this is all values less than, so I'm going to go negative 1, negative 2, negative 3, negative 4. And all we're going to do is just substitute these values of x into our function. Okay, so this is our input, and then we'll get an output. So negative 1 plus 3 is positive 2. Negative 2 plus 3 is positive 1. Negative 3 plus 3 is 0. And then we get negative 1. And then to graph this, we'll start at 0, 3. At 0, 3, again, I said we're going to do an open circle. Then negative 1, 2, negative 2, 1, negative 3, 0, and negative 4, 1. Okay, and that is this piece of this function. For our next one, x is greater than or equal to 0. Again, we're going to include 0, but when we use 0, we can use a closed circle for that. We just put 0 in for x, so it is going to be negative 1. And then again, this is all values greater than 0, so 1, 2, 3, 4. I'll put 1 in for x, so 2 minus 1 is 1. Then we have 2 in for x, so 4 minus 1 is 3. 6 minus 1 is 5. 8 minus 1 is 7. Okay, and then we'll go ahead and plot these points on our graph as well. So at 0, negative 1, it's a closed circle. Then we have 1, 1, 2, 3, 3, 5. It looks like 4, 7 is going to go off the graph. And so I have enough other values. I don't need to worry about trying to squeeze that in. So this is my piecewise function. It says describe the domain and range. So I'm going to just go ahead and do this off to the side right here. My domain. So this is left to right. A reminder of that. And so from the left, my arrow tells me it's going to go on forever. To the right, in the right direction, the arrow tells me it's going to go on forever. So infinity to infinity. For range, okay, again, we go down to up. The down arrow tells me that it'll go down for negative infinity, and then the up arrow will tell me that it goes up for infinity. And another way that you can write this is that this is all real numbers. And lastly, the last way that we could write this is negative infinity is less than x, or y, which is less than positive infinity. So just a reminder that of all the different ways that you can write it, the different notation, you have to be familiar with all of them. So I'll just have the y in there since it's closer to range. The last thing on this front page is why does this function pass the vertical line test? Okay, so if you remember the vertical line test, our vertical line cannot pass through more than one point. So that's where with this piecewise function we have an open circle with a closed circle. The open circle makes sure that this happens, that it does pass that vertical line test. So we'll go ahead and answer this by saying no vertical line passes through more than one point. Even at when x equals 0, so this is where x equals 0, the only output is negative 1, and that's because we have that closed circle right there. So that's our only output. All right, let's go ahead and turn the page. And we will end up trying this again. So, sorry, I had a weird pop-up on my computer. That's why I had a pause there. So make a table and graph this piecewise function. So, again, this is all values of x less than 0. We're going to start by using 0, and then we're going to write down the values less than 0. So negative 1, negative 2, negative 3, negative 4. Okay, and then let's go ahead and substitute 0 in for x and solve. And so we get negative 4. We have minus a negative 1, which is a positive 1. Minus 4 is negative 3. Minus a negative 2 minus 4 is negative 2. Minus a negative 3 minus 4 is negative 1. And minus a negative 4 is 0. So let's go ahead and plot this. We're going to start at 0, -4 with an open circle. Then we'll go -1, -3, -2, -2, -3, -1, and -4, 0. And then go ahead and graph this line. And then we'll do the same thing for the other one. So we have 0, x is greater than or equal to 0, and then other x values increasing. Okay, again, according to that inequality rule. Then we substitute our x values in for x. So we get 0, 1, 2, 3, 4. Okay. We're going to start at 0, 0, 1, 1, 2, 2, 3, 3, and 4. And draw your straight line. It says describe the domain and range, so we'll do that real quick. The domain, again, from left to right, arrows tell me all real numbers. My range, bottom to top, my lowest y coordinate is -4. So my range is going to be -4, less than y, less than infinity. It's not going to equal -4 because the open circle. Another way that you could write this is y is greater than -4, or you could also write it as -4, comma, infinity. So any of those will be acceptable. Let's go ahead and ask and think about, why does this function pass the vertical line test? Does our vertical line pass through more than one point? You're going to say no. It only passes through this one point at 0, 0. So let's write that down. No vertical line passes through more than one point even at x equals 0. The only output is 0. Okay, so we're talking about at 0, 0. We have -4, but again, it does not equal, so it is not going to be an exact output, an equaling output. All right, problem number 3. Problem number 3 talks about, this is a story problem with Piecewise. So a gym owner wants to purchase a custom wristbands for a marketing promotion. She thinks she will need about 75 bands. Her assistant insists that ordering over 100 bands will be less expensive than ordering 75. How can the assistant convince the gym owner? So what we're going to do real quick is, it is a story problem. We're going to label our variables. So we'll go ahead and label x as the number of wristbands, because again, we'll be writing equations for this as well. And then we can have y, but remember y is also f of x, is going to equal your total cost. Okay, so we're going to just kind of rewrite this bit of information in the I guess table, the advertisement, whatever you want to call it, as somewhat of functions. So if we have 0 to 50 wristbands, it's going to be $2 times that number of wristbands, but plus $20 shipping, right? If we order 51 to 100 wristbands, it's going to be $1 per wristband plus the $10 shipping. And then if it's more than 100, it's going to be 50 cents for each one, and then we don't have to worry about shipping. So this is kind of summarizing and writing down what this table means just mathematically. The next thing that I'm going to ask that you guys do is we're going to write a piecewise function for this. Okay, so piecewise function is where we have f of x equal to, and then we're going to write this all as equations. So we'll start with 2 2x plus 20, and then we're going to write this in that interval notation. This is for 0 to 50 wristbands. Okay, so that's in that interval notation. Then we'll do x plus 10. In the interval notation, it's going to be 50 to exactly 100. So this is all of your x values greater than 50. Okay? And then the last one, 50 cents, and this is for all of them greater than 100. Then we use the curly bracket to signify that it is a set. Okay, so this is what I'm looking for when I ask for you to write a piecewise function, just like this. Now, to keep convincing the gym owner, let's find the cost of 75 wristbands versus 101. So more than 100, we'll just go with 101. So we'll start with, for 75 wristbands, we have to use the middle function right here. So it'll be 75 times 1 plus 10. So 75 plus 10 is 85. So we could write 75 wristbands equals $85. And then to compare, more than 100, that's supposed to be 101, there we go, 101 is 50 cents times 101, that's 50.5, okay? So we can say 101, can't seem to write that 101 today, wristbands is $50.50. So just showing your algebra is a way to convince that gym owner. Okay, let's go ahead and get to our last page. Our last page here is a review. Okay, so we are reviewing a type of problem that was commonly missed on your last test. This is comparing functions. So 3 trains leave a station at the same time. What is the rate of change for each train? So a quick reminder on rate of change, what that means. Rate of change, we write that as rise over run, change of y over the change of x, okay? So, and then this all is m, which is slope. Okay, they all mean the same thing, just different notation for all of it. Let's go ahead. It says what's the rate of change for each train. If we start with train A, okay, we'll just go right here. This is from 0, 0 to, if I take a look at it, it looks like it's going to be 260. So we go up 1, 2, 3. But when we go up 3, we're really going up to 60. So I'm going to write in 60. And then we go right 1, 2 over 2, which simplifies to 30. Okay? For train B, we can just pull it right out of the equation. It's 45. For train C, remember our table is XY. So it's the change of Y over the change of X. So 3 to 6 is an increase of 3, 6 to 9 is an increase of 3, and then 9 to 12, increase of 3. 105 to 210 is an increase of 105, another 105, and then lastly 105. So when I write the rate of change for C, it's 105 divided by 3, which simplifies to 35. Okay, this is the rate of change for each one. Order the trains from least to greatest speed. Okay, least is going to be A, then C, and lastly B. Okay. And then the last problem that I have for you is, again, which function has the greatest rate of change? We need to find the rate of change of each. So for our table, 1 to 2 is 1 to 1 and 1. 5 to 8 is 3, 8 to 11 is 3, 11 to 14 is 3. Again, remember it is y over x, so it's 3 over 1 for the table. For our graph, We go up 1, 2, 3, 4, or you can find the difference from 300 to 100 is 200. And then 1, 2, which I look down here on my x-axis, it's 50. This simplifies to 4. Okay. And then it says which one has the greatest rate of change. So we would just say function B. Okay. All right. That's it for these notes. I hope it went well. I look forward to seeing you next time in class.